All right, if you've tuned in, I'm just getting things set up for the live stream now. This is Workout Wednesday. Sorry, it's a bit late. I had some tech issues trying to get this set up. If you're joining in, then give us a wave in the live chat. Just let us know that you can hear this okay. And then I'll get started answering some questions. All right, so hopefully what's happening is this is being live streamed out to Instagram and Facebook and YouTube all simultaneously. And we should be able to go through some organic chemistry questions that I've had from people across the various social media platforms. Okay, so I'll just bring up the chat window, make sure I'm not missing any comments. So here we are. So we've got a few people joining in. Thanks for joining in. Welcome to the Workout Wednesday. Just making sure that all the channels are up and running. Okay, if you just joined in, then this is just the live stream Workout Wednesday where I'm going to go through some organic chemistry problems. I'll just see that I think there's a problem with the Instagram feed, so I'll just see if I can get that working. Bear with me a moment. Okay, thanks for your patience. I was just having a bit of trouble getting the Instagram live stream to happen. So once again, my name is Mark Costa from Organic Chemistry Explained, and I wanted to set up these Workout Wednesdays as a way of getting questions from you and then answering them in a live fashion and hopefully putting out the recording as well. So I'm going to start the recording, and I'll go through questions that have come to me via the various social media platforms. So welcome to the live stream if you're tuning in on Instagram or Facebook Live or YouTube. Hopefully we're streaming out to all those platforms at the moment. I am going to go through a couple of questions today. And if you have any more questions, then send them through to me by whatever platform you like, and I'll go through them on these Wednesdays. So I'm just having a look at some of the questions that are coming up here on Instagram. Thanks for joining, Emily. So you're asking about Newman Projections. I've actually got a video on Newman Projections, so I might, at the end of this, direct you to that. But if you have any more questions, maybe just pop them into the thread and I can go through them next Workout Wednesday. I'll see how I go for time. I might give you a few tips about that as we go. So for the Instagram live feed, I'm just going to move the video out of the way so you can see my screen a bit better. Okay, so what I had come through on the Facebook group Organic Chemistry Help is a question about doing SN1 versus SN2 reactions on a particular bromide. So I've got neopentyl bromide here. So this compound is called neopentyl bromide. And it's an unusual case of an alkyl halide because if you look at the carbon where the bromine is attached, that carbon there is a primary carbon, But the carbon next door to it here is tertiary. Okay, and that means that it's highly hindered. The position bearing the bromine is highly hindered, but it's also primary. So it's not favored by SN1 or by SN2. So what do you do about this situation? So if you're asked about the reactions of neopentyl bromide in an exam situation, really the first thing you want to say is that you have slow reactions, whether it is SN1 or SN2. Now, the way this was asked on the Facebook group Organic Chemistry Help was, what are the products of an SN1 versus an SN2 reaction? So if you do manage to get an SN2 reaction happen on neopentyl bromide, then there's only one option. SN2 reactions have to go with displacement of the leaving group with no intermediates. So we have to get displacement of the bromide via a transition state that looks quite hindered, but is the only real option we have. So we'd have the hydroxide nucleophile coming in as the bromide leaves, and so even though this is primary, it's going to be quite slow because we've got the steric hindrance from these alkyl groups. Okay, so the three alkyl groups and the carbon next door are really slowing down this SN2 reaction. And so when it does occur, it's just going to give the expected product. So it's just going to give the alcohol like that, but it's going to be extremely slow. Okay, so in the SN2 case, nothing unexpected happens, but it's just an extremely slow reaction. In fact, compared to methyl bromide, I think the rate of this is around 3 million times slower. So very, very slow reaction. Now, when we get an SN1 reaction occur, this is different conditions. Now we're going to be using water and heating. So this is just going to be a solvolysis reaction. So we're going to take the neopentyl bromide and we're going to put it into water and then just heat it to a very high temperature until the reaction occurs. And so for an SN1 reaction to occur, we have to get the leaving group to depart. So we're going to make this bromide leave like that to generate a carbocation. So when we generate that carbocation, it's going to be a primary carbocation like this. And in fact, primary carbocations are so unstable that primary carbocation doesn't fully exist. It actually undergoes reaction as that leaving group is leaving. A reaction occurs, so it's not quite a carbocation, but sort of close to that. So hopefully I didn't muddy the waters there. But what happens is when we get very unstable carbocations, they like to rearrange to something more stable. So if that's a primary carbocation, and we can get a methyl group, so let's just move this one here, it can be any of those three because they're all equivalent. We can get that leaving that methyl group migrate with its pair of electrons to the carbon next door to make a much more stable carbocation. So when that happens, we're going to get those two methyl groups there haven't moved, and then we've got a methyl group here that has moved, and the position where the methyl group moved from is going to have the positive charge. So now we've got a 1, 2, 3 alkyl groups on that carbon atom. So now this is a tertiary carbocation, and we've got that new methyl group that's migrated. Okay, so then that is much more stable. It has a finite lifetime, and it will eventually find a water molecule and undergo reaction with that. So the solvolysis will occur on that tertiary carbocation. So we'll initially get a molecule that will look like this with the water having added, and that oxygen will have the positive charge like that. And then we're going to lose a proton from that water. So let me just draw out that so that's easier to show the proton being lost. Okay, so when that proton is lost, we might draw that above the arrow as minus H plus. And we can just draw like this, the proton going, the OH bond breaking, the electrons going onto the oxygen. Although for completeness, we probably always want to show a base doing proton transfers. So with phospholysis, it's just going to be the water coming in, and that is going to act as the base to pull off that proton. And so when we solvolize neopentyl bromide in water, we're going to get, the product is this alcohol there, like that. So it'll actually give you a secondary alcohol where the carbon skeleton is rearranged to give a different product. Okay, so just recapping, neopentyl bromide, it's a primary alkyl bromide, but with an extremely hindered position next door to that carbon atom with the bromine attached. And so that makes both the SN1 and the SN2 reactions quite slow. And therefore, when the SN2 reaction happens, it's 3 million times slower than with methyl bromide. And when the SN1 reaction happens under different conditions with a weak nucleophile, just water, and with a lot of heating, when the carbocation is generated, it actually rearranges before you get it being trapped with water. Okay, so I'm just going to go back to look at the comments on Instagram here. So thanks for everyone who's joined in. We've got a bunch of people asking a few questions. So for this live session, unfortunately, due to the tech problems, I started a bit later than I wanted to. There was a question early on from Emily about Newman projections. I've got a question from Linchan_officiel. How is the most effective way to memorize notes regarding chemistry? So a couple of things there. What I want to do is I will just quickly show you about Newman projections. And then I'll point you to a resource I've made. So I've got a video about Newman projections on my website, organicchemexplained.com, and so you can go there and have a look at this video about Newman projections and get some hints there. Okay, so I'm going to just bring up a new page. So bear with me for a moment. Okay, so Newman projections, where we've got a molecule like this, and say we've got a hydroxyl group like that, and we want to draw a Newman projection of this molecule to show the stereochemistry or the conformation of the molecule. So first thing I would do is draw in your implicit hydrogens on the carbon atoms that are important for the Newman projection. So if I want to draw a Newman projection of this molecule, and I'm looking, here's my eye, I'm looking along this bond here, I want to draw in all of the things attached to the two carbon atoms that are along that bond. So I would draw in the implicit hydrogens there that we normally don't draw in. And then what I want to do is imagine myself looking down that bond, and how would that bond look if I was looking down it? Okay, so this is much easier to see with models, and in the video that I'll link to after this session, I show how to go from the model to the Newman projection on the page. So if we look at this and we want to draw this as a Newman projection, so here's our equivalence arrow. What I want to do is imagine as I look along this with my beady little eye, this methyl group here is pointing sort of up. And so first thing I want to do is draw a methyl group there. So there's my methyl group, and it's going directly upwards. And then if I imagine myself as this eye looking along that bond there, as I look along that bond, down and to the left is a hydroxyl group. So down and to the left is the hydroxyl group like this. And then down and to the right is the hydrogen. Okay, so there's our first three substituents. So we've looked at all the substituents on this first carbon atom here. So now let's look at the other carbon atom. I'll do this in blue. And now this back carbon atom, what we do for a Newman projection is we draw that as a circle. So we draw this as a circle like that. And then I want to imagine, what does it look like? Well, the thing that is in the page here is the other methyl group. Okay, and as I look at it, I'm looking along this bond here. As I look at it, I imagine myself looking along that bond, and downwards within the plane is the methyl group. So It's going to be directly in front of me, but going down. And so we're going to draw a methyl group going down from that circle. And then the other two things I've got are two hydrogens. So this is a little bit of a boring Newman projection here. There's no other stereochemistry to draw in there, but I have drawn in the conformation of that molecule according to how it's been drawn in that line bond structure. So hopefully that gave you a few tips. I'll link after this. Maybe I'll do an Instagram story and put it out onto other platforms. A link to the video that I made about Newman projections that goes through in much more detail with molecular models how to draw those. Okay, so what other questions do we have here? We've got how is the most effective way to memorize notes regarding chemistry? So my number one tip is flashcards. Not many organic chemistry students use flashcards, and the often quoted thing is that for organic chemistry you want to stop memorizing and learn the overall systems and the overall approaches and guidelines and things like that. But I would say that to get good at organic chemistry you have to do both. You have to do memorization of the fundamentals. You have to memorize things like functional groups, names of molecules. You have to memorize how to do certain things. And then you have to do a lot of practice, which is not really memorization. You have to do a lot of practice problems, and you have to go through and really try to challenge your understanding of things with those practice problems and go through worked examples of the answers to them to test your understanding. I think the flashcards are a great way to do this, and I'll also, after this live session, link to my blog post about flashcards for organic chemistry. I've made a bunch of these on Quizlet, and I think they're high quality because I've got a diagram for every single concept, whereas most other flashcards you find online for organic chemistry don't have diagrams, they're just text, and I really think that's not the best way to learn organic chemistry. So there's a few tips about how to memorize your notes for organic chemistry. So just going through all the questions here. Thanks for the wave, Ace Schooling, that's really nice of you to join in. Ace Schooling says, to be honest, the main thing organic chemistry taught me was how to draw hexagons. I completely agree, there's a lot of hexagon drawing, and that's why I made these templates for helping you draw organic chemistry structures. So if you go to my website, organicchem-explained.com, you can get access to these templates that really help you with drawing these hexagonal structures, and also the bond line structures, and even the Newman projections, which are all based on this hexagonal framework. One last cache, thanks for the emoji there, that's really nice. Chrissy Chan, hello, thanks for joining in. Ace Schooling says, organic chemistry is difficult. Those who study it have all kinds of troubles. That's a really good joke, one of my favorites. Thank you for that. Okay, so that's all the questions I had today. Come in before the session. I had the one I went through earlier in the session about the neopentyl bromide was from the Organic Chemistry Facebook group. If you're a Facebook user, then please come and join the group, Organic Chemistry Help. It's free, and you can ask questions and get, we've got over 1,000 people using the group now. People really step in and answer questions. When I can, when I have time, I step in and help out as well and moderate the group. I do this every Wednesday. This is my second time. There were some technical issues, so we're running a bit late today. But next week, I think we'll be much more on track. And if you have any questions during the week leading up to Wednesday, please get them to me by any means possible. By Instagram, by Facebook, shoot me an email. My email address is on my website, organicchem-explained.com. Thanks for joining in, and I'll see you again next week. Bye-bye.